Well, I hope everybody did a good job on 1.3 with the frequency tables. So, starting chapter 2, so we actually want to do kind of a graphical. So, everything in this section is going to be taking the data and now turning it into some kind of graph where we can visually see kind of what the data looks like. So, in future chapters, what we're going to do is we're going to measure things with numerical summaries. So, just to kind of give you a brief overview of where we're heading in this chapter. So, one of the main things that we want to do with numerical measures is figure out where a data point falls in the data set. So, where a data point falls. So is it in the middle? Is it to the left? Is it to the right? So if you think about it kind of as a number line, like where would the data actually live? Where would these different points live? So with that in mind, another main thing that we want to know is where the data is centered, or where is the center of the data. We also want to know about the spread of the data. So is the data symmetric or is it skewed? And then finally, how spread out is the data or how clumped up is the data? So again, that's not what we're going to work on now, but that'll be kind of how we finish up chapter 2. So these will be more like where we're actually doing something with the numbers instead of just visualizing them and things like that. So again, this is for the future, so just kind of keep that in mind. That's where we're heading. So with that in mind, what we're going to do is we're going to talk about two different kinds of graphs here that look similar when you look at them, but they do have subtle differences. So I want to talk a little bit about each of the differences before we actually kind of go in and graph them. So what we want to talk about are bar graphs and histograms. So a bar graph consists of bars that are rectangles that are not touching each other. So if you think about them, the bar graphs are social distancing. So they're trying to keep a distance between themselves and the other ones. So this consists of bars. So these guys are social distancing. They're not touching. They're staying 6 feet apart. So that's the thing to remember about bar graphs. So bar graphs could either be vertical or horizontal. So and they're often used for categorical or qualitative data, the non-numeric data, just because those things are already separated from each other anyway. So these are often used quantitative. So if you imagine in the last section when we did the letter grade one, it wouldn't make sense to do kind of a histogram, not even that we know what a histogram is, but because A, B, C, D, and F are all kind of separate anyway, so it would make sense if we were graphing that to graph it as a bar graph in that case. So in this case, it's used for quantitative, non-numeric data. Because the category, not the data, the categories are kind of naturally separated to begin with. All right, so that's a bar graph. So a histogram, on the other hand, consist of bars that are not social distancing, so they're actually touching each other. So they're touching each other. So typically, like about 99% of the time, and for our class, 100% of the time, the bars are always going to be vertical for histograms. So the bars are almost always vertical. So for us, they will always be vertical, but occasionally you can have horizontal histograms. But two, they're often used for numerical data. So qualitative. Oops. And since again, numbers kind of flow one into the other, so it makes sense that you would have these bars actually touching each other in the case of qualitative data. So the horizontal axis, or think about it as the x-axis, is always labeled with whatever the data represents. So if you were talking about hours worked or miles driven or something like that, then that's how the x-axis would be labeled, or the horizontal axis. So the vertical axis, on the other hand, is always going to be named either frequency or relative frequency. So, because again, what we're doing when we make a histogram is taking our frequency distribution chart and kind of graphing it. So in this case, the vertical axis is always labeled frequency. Or relative frequency. And finally, the histogram contains exactly the same information as the frequency table. If you actually imagine kind of drawing bars around the frequency table, like you could imagine, almost imagine what the histogram would look like. So the histogram contains exactly the same information it's just in graph form in that case. All right, so that just gives you a little bit of a summary. So now let's look at some possibilities here. So in this case, here's example 1. So we've got a cities broken down into 6 districts. The following table shows the percentage of the total registered voter population that lives in each district, as well as the percentage total of the entire population. So again, notice our categories in this case they're numeric, technically 1, 2, 3, 4, 5, 6, but they're districts. So it's not like you could add them up and get different districts. So this really is quantitative data in this case, or qualitative data, the categorical data. And so if you notice down at the bottom, our city districts are labeled at the bottom, 1, 2, 3, 4, 5, 6. Along the side here, so again, this is our bar graph. So we've got percent of voter population. And so this column has already been drawn for us. So again, notice there's social distancing. All the bars are separated from each other. Nobody's touching each other. And then they kind of wrote the numbers on top, which is like a nice little touch. You don't have to do that, but it looks good. So what we want to do is do the same thing down below, but now we want to graph the overall city population. So again, what we want to do is kind of graph it the same way. So notice when we draw our bar graph, what we're trying to do is we're trying to center our rectangles kind of around those categories at the bottom. And again, we want to make sure we leave some space so no one's touching. And again, it's tough to draw these. These are all decimals, so do your best to try to approximate them. You know, we can't get them necessarily exactly right, but do your best, making sure it looks good. So the first one we want to draw is 19.4. So again, I'm going to draw my rectangle a little bit to the right of this. So I'm going to go almost up to 20, come over, and then drop down. And then if you want, And put a little 19.4 up there so we know what that represents. So next one is 15.6. So again, I want to make sure I don't want any of these guys to touch in. So I want a little bit more than 50, or a little bit more than 15. And then we've got 9.0. And then 4 is 18.5. Look how straight these lines are. I'm awesome. 20.7. So in this case, we're going to go a little bit above 20. Phew, my lines are getting worse and worse here. Jeez. And then finally, 16.8. This would obviously be easier if we were using graph paper or something, but we work with what we've got here. All right, so that's semi-perfect looking. So again, main thing is for a bar graph, just make sure the bars aren't touching. If you want to color them in, you can color them in, things like that. But really the key is the main difference between a bar graph and a histogram is the fact that one is social distancing, the other is not social distancing. So kind of keep that in mind. All right, so there are some other cool things that you can do with bar graphs. So in this case, if we look at this top bar graph, what they've done is they've actually kind of compared the voters and the totals. So they've taken these two pictures above and basically merged them together. So if you notice 15.5 and 19.4 for District 1 is exactly what we've got here. So the graph I drew is in red, the original graph was in blue. So it kind of just gives you a comparison that you can compare these guys together. So another thing that you can do is you can actually order them from lowest to highest. So now again, be careful because notice, because we've ordered them lowest to highest, we had to, we couldn't just leave it 1, 2, 3, 4, 5, 6 anymore. We had to move the districts along with it. So if you happen to do this, make sure you change the bottom descriptions as well. And so what this is called when you order things from lowest to highest is a pair-to chart. So again, there's some other things involved, but that's kind of the main feature of it. So we're not going to work with those necessarily, but just to give you a hint about it, there you go. All right. So finally, what we want to do is now we want to do a histogram. And so this is using data that we had from the last example from 1.3. So again, we had iPads that were sold over the last 50 days. We calculated our frequency, our relative frequency, and so there's the decimals that I didn't have before. And so now what we want to do is draw our histogram. So now unlike the bar chart, so remember the bar graph, the idea was we tried to center the bar in the middle of the number. So here I want to actually start wherever this value is and end where the next value is. So again, I don't want to leave any gap. There's no social distancing going on when we're talking about a histogram. So in this case, for value 0, I want to do a frequency of 5. So I actually want to start on the 0, go up to where 5 would be, go the whole way over to 1, and then drop down. And so here, we typically don't put the number on top. I mean, if you can, it's fine. It's not wrong or anything like that. But a lot of times you won't see a number necessarily on top of a histogram, but it's fine to do it if you want to. So now for 1, we want to do the same thing. So we want to start where this one left off, go up to 8, go over, and then again drop down right on 2. So there's our 8. So 2 goes out to 14. So we're going to go again, start here, go up to 14, go over to 3, drop down. So 3 starts at 13. So that means I want to start kind of partway in the middle here, go over to 4. Ooh, that was ugly. And then 13. So 4 starts at 6. So I'm going to start way down here, go over to 5. And then finally, 5 goes out to 6. So even though 6 isn't on our list, I want to make sure, just like on our frequency diagram, like all the class widths are the same, I need to make sure that these histograms all have the same width also. So that's why, even though we're not including 6, I've got to go out to 6 to make sure they all have the same width. So in this case, I want to go 5 is up at 4, go over to 6, and then down, and then that gives me my 4. So there's a nice histogram of the given data from above. So not too terrible. The lines are a little crooked, but I'll take it. So if you have any questions about that, just let me know. So otherwise, here's one for you guys to work on. And here's another one for you guys to work on. And a third one for you guys to work on. So these again, so the main thing we're trying to do is we're actually trying to calculate the different histograms in this case. So you guys work on these on your own. So I'll actually, the one I uploaded, I downloaded the wrong one. So the one I worked on, we already have the frequency chart done for you. So I must have picked up an old copy. So you won't have to redo the frequency distribution for these. So you'll only have to do the histogram for each one of them. But if you have questions about it, let me know. Otherwise, stop this video at the moment, work on the rest of this packet, and then come back for 2.2 video.